All right, so we are going to talk about defrost. Kind of break this down in a couple of different modules so I can shorten up the lectures a little bit and focus on different parts. So this one in particular is going to talk about the electrical side of the defrost circuit, specifically the defrost board, and what happens, how that defrost board does what it does. I've posted some videos, and honestly, those videos are probably just as good, if not better, than anything that I'm going to be able to show here. We'll go over this in class as well, but watch those videos because they're using real equipment. They've got up close video. They're doing a better quality than I can do. So check those out. But in the meantime, I do want to show you a couple of things. So first of all, why do we need a defrost board? We need a defrost because that unit could go below freezing. The coil could get below freezing, stay there for a long time. Obviously, if it's sitting outside, it's going to be, could be colder than freezing pretty easily, because even if it's above freezing outside, that coil is going to need to be about, or that saturation temperature is going to need to be about 20 or so degrees, 30 below. Most time we're more like 20 below, I think, on the heat pumps on the outside. So your indoor minus 30, outdoor plus 20. On a heat pump, that's going to change a little bit, and that's going to be more like outdoor minus 20, maybe even 15, indoor plus 35, 40, 45. It's going to run a little hotter because of the surface area like we talked earlier. So we'll get into more of the specifics on that. But, we know basically that it's going to get colder and it's going to freeze, so we need a defrost. Now, how does the defrost board work? So what all goes to that board, first of all? I'm going to pull this up, and there's a video or two where the guy's actually referencing this exact picture. But I wanted to go through it a little bit myself and just show you a couple of things. So this is sort of a generic defrost board. There's a lot of different configurations. I'm going to go through and actually show you a few different styles, different brands. So this isn't the end-all be-all. This isn't the way they're all set up, but this is the basic operation of one. So what a defrost board is doing is it's receiving a signal from your stat for all the functions that heat pump's going to have. So a basic heat pump is going to have red, yellow, common, orange or blue, depending on which direction the reversing valve is switching, and then it's going to have W. All right, so without going too far back into the other episodes or into future lessons, I'm just going to stick to the board right now. So you got red coming from a stat. So your red is going actually from the air handler, not from the stat. So the air handler is your hub. The air handler is where your power is coming from. So your red and your common are feeding back to your transformer. Your red is feeding your thermostat, and then your thermostat is telling everything on its end what to do. So if it's saying we're calling for heat, we're calling for cooling, whatever, then it's sending that 24 volts from red to all those places. What I want you to think of is that this board is essentially a second thermostat, that it has the ability to do pretty much the same thing. It operates much in the same way. And so it has red coming to it, just like the thermostat does. It has a common going from it, just like the thermostat may if the thermostat is consuming power. So this board is going to have things that need common. So it has to have a common. It's not an option at this point. So red, common, orange or blue, depending on brand. Most brands use orange to reverse, and that means that it is, I got to remember how this is. Orange is energized. Let's see. Orange is normally heating, energizes to cooling. Blue, which is Rude, Ream, there's a couple other brands that use blue, is the opposite. So blue defaults, I think I'm telling you right. I got to remember on that now. But it goes the other direction. So don't hold me to that. I've got to look that up. Wasn't prepared to talk about the reversing valve right now, the refrigeration side. So, but yeah, you're going to use your O and your B. So if you're using blue for reversing valve, so in the case of like when I hook up my reams or Rudes, I'm hooking up blue to OB, O or B. So I can't use blue for common. Most of the roods or reams use brown as common. So just keep that in mind. Don't assume that blue is always common, brown is always emergency heat or whatever, because in those they use brown for common and blue for the reversing valve. So anyway, you got your reversing valve wire. So these three, red's getting power from the stat or from the transformer. Common is getting power, sending power back to the transformer or neutral. Orange is getting power from the thermostat. So the thermostat is dictating by the position that it's turned on, whether it's in cool or whether it's in heat, whether that orange needs to be energized or not energized. So as soon as you switch that to cool or heat, so let's say, for example, that you switch it to cool, and on that particular system, cool is energized, so it gets 24 volts. Well, the stat is sending 24 volts from red inside to orange outside, going through the air handler, but it's just bypassing the air handler and going straight to the outside unit, and that's going to be on all the time. So it's always going to be in that position, because as soon as you switch that stat to cooling, that's going to energize or de-energize that reversing valve depending on its position. Then when it goes to kick on, it's going to just bring it on in the right mode. Now, this O or B can switch when it comes to defrost, but for normal operation, it's just going to stay put whichever way it's in. And then when you turn the system, the thermostat off, it's going to go into its normal position. So it's going to be energized or de-energized, cooling or heating. The next one is yellow. So a lot of people mistakenly think that yellow is cooling. Yellow is cooling in air conditioning or on an air conditioner, but in heat pump, it's heating as well. It's your first stage of heat. So we think that W is heat because that's the way it is on a furnace or a single stage. But on a heat pump, your first stage of heat is Y. And Y energizes your compressor contactor. So regardless of if it's in heating or in cooling, if it's set up for heat pump, that thermostat is going to send a signal to Y. And it's going to say, okay, we need to run the compressor. And then orange is going to tell you what direction it sends the refrigerant. Now, so what is W for? When the system goes into defrost, a few things have to happen. So this system's running in normal heating mode. So it's just doing its thing. It's projecting heat inside that it picked up from outside. Red is powering this board. Common is sending power back, or neutral back. Orange is telling it what position to be in. Yellow is telling it that the compressor needs to run or that it doesn't. When it goes into defrost, this reversing valve is going to switch positions. So if it's energized to heat, it's going to de-energize. If it's de-energized to heat, it's going to energize. So whatever it's doing to get it into heating mode, it's going to do the opposite, which essentially puts the system back in cooling mode. So here we are in the wintertime. That outdoor unit is freezing up like it's supposed to, like it's going to. And then every so many minutes, it's going to check and it's going to see if it needs to defrost. And if it needs to defrost, then it's going to keep the compressor energized. Then it's going to switch orange or blue, switch the reversing valve back to cooling, which makes that outdoor unit your condenser again. Well, condenser is on the high side, so the condenser is going to get warm, but it's still sitting outside, cold weather, fan blowing across it. Your head pressure is going to really, really struggle to get where it needs to get. So what this board also does is it will kill the condenser fan. So your condenser fan is running, or your outdoor fan is running in heating mode, picking up heat from outside. But when it goes into defrost, the first thing it's going to do is it's going to drop that fan out so that you're no longer moving air across it, so your head pressure will come up, because the higher the head pressure comes up, the warmer that coil gets. The warmer it gets, the faster it defrosts, the faster it thaws, the faster we go back to heating. So we're running this thing in cooling. So now your indoor unit becomes your evaporator. Your blower inside is still running because it has to run or your indoor unit would freeze up. So you're blowing cooling into your house. You don't want to do that forever, obviously, because you're trying to heat this place. So what you're going to do is you're going to also, that board is going to bring in W. Now, what is W? W is your auxiliary heat, your backup heat. In most cases, it's electric heat strips, but not always. But whatever your backup heat source is, that W is going to bring it in. So that is your second stage. So in a heat pump, Y is your first stage, W is your second stage. So you've got a white wire that's coming back from the stat, or back from the board, calling for the emergency heat strip to come on. The thermostat doesn't call for those. The board does. The board does what the stat would do, basically. It bypasses the stat. So when this thing goes into defrost, a few things are going to happen. So I want you to write these down. There are some variations to this as well, depending on brand, but this is kind of the basic overall. So when it goes into defrost, the first thing that has to happen is orange will switch positions. Simultaneously, orange switches position, sends the unit to cooling. The condenser fan drops out. So up here. W energizes by sending power from red in the board over to W. That W sends a back signal back to the indoor unit, bringing on the heat strips. So now you're cranking heat strips over top. You're reheating your cold air, so you're not just blowing cold air into your house that you're trying to heat, which makes sense, right? And so those heat strips are going to come on and try to keep the air, mild, so you're not freezing your house. Once that's done, all that's going to switch back and go back into its original position. Now, you'll notice these other things over to the side, and they're not always exactly wired like this, but gives you a basic idea of all the things that this controls. So these are your inputs: red, common, orange, yellow, orange or blue, yellow or white. So you've got 5 wires coming into a basic single-stage heat pump. You've got 2 high-voltage wires. So what you'll see in lab and later on, you'll see that what we're actually doing here on this condenser fan is we're breaking one leg of hot. So this isn't a low-voltage wire. This is high voltage. These down here are low. So this board has both. This board has low voltage and high voltage on it. So high voltage wires coming in to that board. So if you went to change this board, for example, you needed to change it out. You're going to have to kill the indoor unit to kill the 24 volts. You're going to have to kill the outdoor unit to kill the high voltage. So do both, because you'll blow something, you'll burn something up, or get shocked, or both. So that's just basically breaking one leg to the condenser fan. You'll also notice that the reversing valve is running off of that. Reversing valve is going to have a common on it, and then it's going to have an orange or a signal wire. So this board will get power in on orange, saying that the stat is telling it that it's in whatever position. And then that board, through its internal circuit, then sends that power to the reversing valve when it needs it, kills it when it doesn't. So when the board senses that it needs to go into defrost, the thermostat doesn't know anything about it. The thermostat is completely out of the loop on this. All that the stat knows is that it needs heat and it's calling for it. This unit, this board, is doing its own thing to try to keep the outdoor unit happy. So it's calling for Y the whole time. So we're calling for Y, we're calling for orange to be in the heating position. We're not calling for white right now. That's what the stat's doing. But the board, once it decides it needs to defrost, can reverse this reversing valve on its own. It can also control the contactor. It has pressure switches. So the contactor will have a feed, a yellow in saying, hey, we need for this thing to run. And then assuming everything's in position, so let's say pressure switch, low pressure switch, high pressure switch, for example. If either one of those were bad, we're out. So maybe we're low on refrigerant. We've got a leak and it has tripped on a pressure switch, or maybe the pressure switch is bad, whatever. If one of those switches, or it's on a high pressure and it's, the condenser fan's out, and so it has kicked itself out, that can keep, in cooling or in heating, that can keep the contactor from pulling, which can look like you've got another issue, but it's really something to do with the pressure. So the way you check your board is you're going to see if you've got power coming in and if you got power going out. So in this case, if I had power coming into yellow and then I didn't have power coming out to the contactor, one would assume that it's the board. And we're going to get into that more when we get into troubleshooting, but just to kind of show you how these all work together. But really what it could be doing is it could be opening one of these pressure switches, and the pressure switch is internally wired with that contactor that's saying if the switch isn't made, it's not going to let the contactor kick on. So you have to check everything before you just diagnose this board as bad. But assuming the pressure switches are closed, contactors should kick on and run. Then you've got this little doohickey down here, this little defrost thermostat. And this thermostat is a, it's actually, yeah, okay, so the way you're looking at this, it's kind of backwards. It is a break on rise, make on drop. So it is a heating thermostat, essentially. It's sensing when the temperature gets to a certain low temp, and then it's energizing. So what this stat is doing is it's sensing coil temperature. There's a couple different ways that it can do it, but it's just if it's just a stat, it's just an open or closed, then that stat is strapped to your outdoor unit coil, just physically strapped to it. And I can show you some pictures here in a little while. And so if that thing is strapped to it, it's just going to measure surface temp. So once that thing starts to freeze up, it's going to trip that stat to say, okay, we are in a freezing condition, or potentially freezing, maybe not even freezing, but it is below freezing, so we might need a defrost. Now, just because the thermostat closes and says that we're freezing doesn't make everything go into defrost, because think about it. If that unit's sitting there running and it's 20 degrees outside, obviously that stat is going to be below freezing. So if it called for it every time the coil got below freezing, it would just be in a constant state of defrost. So what it does is that board actually has a timer on it that you set a certain time, 30, 60, 90 minutes usually on a lot of them, that every 30, 60, or 90 minutes, that board will check this switch. And so it's got a clock in it. So that clock starts to count, that motor starts to turn, and after 30, 60, or 90 minutes, that board checks this stat, and it sees if this stat is in a freezing state or not. According to your book, it says the defrost thermostat usually closes between below 30 degrees and opens between 50 and 70, depending on system design. So at about 30 degrees, that stat is going to close. It may stay closed the whole time, but that unit's not going to go into defrost until it times out. So it's going to wait that preset amount of minutes until it kicks itself, until it checks to see if it needs defrost. If it needs defrost, this switch stays closed, then your orange switches, yellow stays energized because your compressor's staying on, your fan drops out, white gets power from red, sends power to the emergency heat, or the auxiliary heat, brings those on, contactor stays energized, reversing valve switches, and basically everything goes through its defrost circuit. There are videos on this module showing different defrost procedures, units actually going into them, also showing you how to physically put one into defrost itself. So that's a really handy thing to do. Like if I got a system that's froze up and I don't know why it's froze, it can only be a couple of things. It's either the board or it's the stat, the defrost thermostat. Now, it could be freezing because of something else, but it should be defrosting. So if it's not defrosting, it's either the board or the defrost thermostat, or maybe it's low on charge or something, and it's not capable of thawing, but it should keep itself defrosted. I'm going to pull up a couple of boards here just to kind of give you a little bit of a practical example. So this board appears to be some sort of ream board. And so you'll notice on this one that you have your inputs. So red, blue, yellow, D. I'm assuming that they're using that for defrost or defrost heat or something. I think on a lot of those reams they use the word, they use D as opposed to W. So that would be your W. And then C would be your common. So you got a couple spots for common if you need an extra one. So 1, 2, 3, 4, 5. And then on your outputs, this one has a Y out. So you're going to have Y in, Y out. Assuming that the board is allowing this compressor to run, Y is going to go out to the contactor, bring the contactor on. And then it has a common coming back, so that's going to let everything, all the commons to that come back. Well, wait. This is its common. So you got Y out and contactor common, I think is what they're going to call that. And then you've got RV, which is your reversing valve. So B comes in, energizes or de-energizes depending on its position, what it's calling for, and either energizes or de-energizes this RV. RV goes out, goes to the contactor coil or the reversing valve coil, and then comes back to common because it has to have a common. Now on this one, if you look on the side over here, you can kind of see where it says DF1 and DF2. So this is your defrost for your fan. This is bringing it in, bringing it out. You just got a L1 or whatever it is, your power wire coming in, power wire going out, and then going to the fan. So power coming in, breaking it. This is normally closed. The only time it opens is when the system goes into defrost. So there are times to where this switch will go bad inside here. So if you ever have a fan that maybe in air conditioning it's not running, and before you assume that the motor's bad, because don't assume anything, check this. So if that board can take that out, the board could have it out. The way you would check that is you would just check across your switches, and if you're not reading 0 volts across that, then that's probably bad. And so you can actually jumper that temporarily if it's in cooling and get you through until you can get another board. There's other ways to jumper a board, and I'll show you that in a future post. But you also got test terminals on here. This one doesn't give you directions on how to test it, but I'm assuming most of them you short these out, short these test terminals, and then that's going to allow it to go in for you to force it into defrost. Now there's something that has to happen in order for it to be forced in. So on this one, you see it's got an outdoor coil temperature sensor, OCT, and an OAT, outdoor air temp or outdoor ambient temp. May or may not always have both of those, or they could look very different, but that's what those are. Over here is your timer. So this one is 90, 70, 60, 50. A lot of them are 30, 60, 90. And you're just going to set that on the combination that you want to give it its time, however long you want it between checks. One thing that's going to really differentiate how much you do that is humidity. If you're in a place that is humid, you're freezing a lot, you're probably going to run that on a shorter time. But if you're in a place that's drier and maybe doesn't need as many defrosts, you could set that up to 90 minutes. Usually I set them on 30 or 60 around here. Okay, now let's see if we can find a different brand. Goodman. All right, so here's one type of Goodman board, a little bit different. So this one has O and O, so an O in and an O out. And I don't think it would matter which one's which on that particular one. It's just an in and an out, looks like. R, so you got R coming in, R going out. DFT, this is your defrost thermostat. Oh, wait, okay, so R, this is probably R in. This is probably R to your defrost thermostat. And then this is the other side of your defrost thermostat, I'm going to bet. So between these two switches, it's going to send power to the stat, to the switch or whatever, and then it's going to check that switch. And if that switch is getting power back on DFT, so if you have 24 volts right here, then it's going to sense that and tell the board, hey, we're freezing. So whenever you're ready, go ahead and bring it into defrost, whenever the timer's up. Here's your timer up here. You've got common, yellow, and W2 or W. So that's your white. That's your heat set back. And then up here's your 2 fan wires. So this is your high voltage. All right. Let's check a different one just to see different styles. And as you can see, there's a lot of different. Well, I'm looking for a train, but I'm not finding one. There's another rain board, a little bit different. A little harder to make sense of. Common, out 24 volt AC, sensor. Yeah, I don't know. That's a little different. Let's go back. All right, let's check this out. Coleman board. This is probably a mobile home unit, Coleman. So this one has red in, common, yellow. These are all your inputs. Red, common, yellow, orange, white. So you should be able to rattle these off pretty quick. What wires do you need? You need 5 wires to a basic heat pump. Red, common, yellow, orange, white. Here's your reversing valve on this one. So this one will have a power out and a power back, assuming one's common, one's hot, and it probably doesn't matter which one. Switch, this is probably some sort of pressure switch. So this is going to be power. So these are different. This one you can't jumper because one side of this is going to go to common, the other side is going to go to red, go to hot. This switch, if it's just a basic switch, you could jumper that. If it is just a thermostat to where it's made, or wait, sorry, pressure switch, sorry. If it's just a pressure switch, so it's not a transducer or something like that. If it's just a switch that is made or broke, and you test that switch and it's open, and you know that you have pressure. So let's say it's a low pressure cutout, and you check it and you know you have pressure, your gauges are fine. You can jumper that out, and that would get you by until you can get something done. In that case, you wouldn't be replacing the board, you'd be replacing the switch. And then this is your stat. So this is your heat pump defrost stat. So power's going out, power's coming back in. If it receives it back in, then the board knows that it needs to defrost. And then this is W. So this is sending power to your white, and then up here is your condenser fan cutouts. So the same basic setup. Here's your 30, 60, 90. Here's your test. So if you're going to test that, there's a few ways to do that. I'm not going to, everyone's a little bit different, so I'm not going to even go through that. So I can find one more that looks a little different. Let's check this one. Okay. No, that's not. That's an air handler board. I think something has got a relay. Oh, I think that's the wrong board. Well, anyway, they all are starting to look about the same. Here we go. This is pretty common, Goodman Amana. Similar to what we have in class right here. So these are your Amana boards, Goodman boards. All right, so this is a lot like the ones we have in class, if not identical. So this one you have R here. So everything's all in one right here. You don't have this, the other side. It's all together. So you've got R, these are your inputs, red, white, yellow, orange, and common. All right, now here's your outputs. Red out to the defrost thermostat back in. White going to the auxiliary heat, yellow coming from the thermostat, operating your contactor. If your contactor's calling, then it goes out on this CNT contactor. So yellow, power out, or power in, CNT, power out. O and ORV. O would be power in, ORV would be going out to the reversing valve. C is your common coming to it, and CRV is common from the reversing valve. So the reversing valve actually has 3 different hookups. So you got orange coming in from the stat, through the board, depending on if it's calling or not. O comes back out, goes to the defrost or goes through the board to the reversing valve, through the coil, back on common, right? So we can draw this out when we get in class, but hopefully you get exactly a little bit of what I'm saying. And then you've got a PS2 and an RPS1. So what this is doing, RPS1 is sending red, 24 volts, out to a pressure switch, and then it's checking that switch, and assuming the switch is closed, 24 volts comes back on PS2. And then here's a common up here, another common. Now, even though they don't look like they're connected, if this R is sending 24 volts, but it doesn't get it back on PS2, Even if yellow is getting a signal 24 volts in, CNT won't get it because it'll keep it out. So if you're in a situation where you're checking a board and you're saying, I've got Y, I don't have this CNT or Y out or whatever, check this switch. Check any switches, see if they're open. If they're open, that's why. Check your pressures, jumper it out. You can make it run. Maybe you get them heat till you get them, get something else fixed. Here's your 30, 60, and 90 over here, and your test. And here's your DF1 and DF2, which is your condenser fan cut out. So that's the ones like we're going to work with in class. So hopefully that helps you on that, gives you a little bit of an idea on the electrical side about what's going to happen. So just to review, what happens when it goes into defrost electrically? First thing that happens, defrost thermostat has to be closed. So once the stat is closed, it sends 24 volts back on DFT in this case. So if we're using this one as our example, R is going to DFT. Once DFT gets below 30 degrees or whatever it's set at, it sends a signal back on DFT. Tells the board, here's 24 volts on this terminal, which means we're freezing. The clock, 30, 60, 90 minutes. When that time is up, there's a little timer in here. I don't know exactly which one of these things it is, maybe this. But there's a timer. That clock, once it reaches its checkpoint, it checks this switch. And it says if this switch is closed, and it really doesn't check it, what it does is if this 24 volts is present, when it goes into that, then it sends it through the circuitry and it says, okay, we have power, we're going to run into defrost. But essentially it's checking the switch. So it checks that switch, assuming that DFT has 24 volts on it, 0 volts across, right? R DFT, it's a switch, 24 in, 24 out, 0 volts across. That means the switch is closed, it's made, it's powered, sending power to the board. The reversing valve, now all the while the thermostat thinks it still needs heat. Thermostat doesn't know any of this is going on. Y stays running, C and T stays running, unless it's made in such a way. Some of them do actually kick it out momentarily and then bring it back on, but for our purposes, let's just assume it stays running. And then O stays in the position on the input because the stat hasn't changed, but the output changes. The board changes the signal going out to the reversing valve. So it drops out or energizes the reversing valve to switch it to cooling. At the same time, DFT, the DF2 and DF1 kills your condenser fan, your outdoor fan. It runs until this DFT opens up, defrost thermostat. So according to your book, it's going to reset at, usually opens between 50 and 70 degrees, depending on manufacturer. So at whatever point that it senses that coil is above freezing and it's warm enough that it should be fine, it's going to open that switch. Once it opens that switch and the board loses this 24 volts on DFT, it's going to go back to its normal operating. So it's going to re-energize, switch the reversing valve back. It's going to bring the defrost or the DF1, DF2 back in, bring the fan back on. It's going to go back into heating mode. Everything's going to run like it should. So that's the electrical side of defrost. So hopefully that helps. And like I said, we'll go over this a lot. This is really something I want you all to understand. So stop right there.